Alright, example 4 of finding the vertex, max or min, axis symmetry, domain and range of this quadratic equation in standard form. Now the first technique is to use this little formula, negative b over 2 times a, which is also the x-coordinate of vertex, which is also the axis symmetry of this equation. So let's see. Our b in this case negative 12, our lowercase a is positive 3. So this this formula is the same as saying negative of negative 12, my bad, over 2 times a, which is 2 times 3. Well, negative of negative 12 is positive 12 over 2 times 3, which is 6. But 12 divided by 6 is just 2, so the x-coordinate of vertex is 2. And of course, axis symmetry at x equal positive 2. So that's one thing we found right here, as a symmetry. Now what about the y-coordinate of vertex? Well, the y-coordinate of the vertex can be found by plugging in the x-coordinate of vertex. So let's call this equation f of x. Well, if x equals to 2 right here, then that means y is going to be equals to 3 times 2 squared minus 12 times 2 plus 15. Well, let's say 2 squared is 4, 3 times 4 is 12. So we got 12, negative 12 times 2, which is minus 24 plus 15. 12 minus 24 is negative 12. Negative 12 plus 15 is positive 3. So the y-coordinate of vertex is positive 3. So the vertex h comma k is equals to 2 comma 3. Axis symmetry is what we found earlier. Now, is it going to be the minimum or the maximum? Well, it is going to be the minimum because algebraically your function is multiplying by a positive leading coefficient. So that means the parabola that opens upward, let's see, 2, 3, the parabola that opened upwards that represent this function is going to have the minimum at y equal to positive 3. So algebraically, that's how we determine that. But graphically, because your parabola opens upward, your function goes from decreasing, hit the vertex, and then switches to increasing. So that's how we know that it's going to have the minimum at y equal to at the y-coordinate of vertex. Now, what about the domain? Well, algebraically, the domain, if we take a look at our function, algebraically, we don't have any denominator, so we can take any x value from between negative infinity to positive infinity, plug it into the function, and we'll be able to crank out the corresponding y value of that specific x value. Graphically, by looking at the x values from left to right, from negative infinity to positive infinity, we don't have any point of discontinuity on the function on the parabola. So that's why by the algebraic way and by the graphical way, we know the domain goes from negative infinity to positive infinity. What about the range? Well, to find the range, you have to graph the function, which we did, the rough sketch, and we had to read the y values of this graph from the lowest y value all the way to the highest y value. But the lowest y value is positive 3, and we don't have any point of discontinuity at y equal positive 3, so we have the bracket at the y value positive 3, and your function is going to keep going up infinitely. So that means the y value is going to go all the way to infinity. So the range is going to go from including y equal 3 all the way to positive infinity. And that's how we find all of these characteristics of these equations.